Please subscribe and you can download this code from description below. The pseudo-spectral method is a powerful numerical technique used for solving partial differential equations, PDEs, in the field of scientific computing. When combined with the Runge-Kutta fourth order, RK4, integration scheme, it becomes a robust approach for simulating a wide range of physical systems. In this tutorial, we will implement the pseudo-spectral method with RK4 in Python, providing a step-by-step guide and code examples. Before we begin, make sure you have the following installed. The pseudo-spectral method is based on representing a function in the spectral domain using Fourier series. It transforms the original problem from the spatial domain to the frequency domain, simplifying the numerical solution. The Runge-Kutta fourth-order method is a widely used numerical integration technique. It provides a good balance between accuracy and computational cost, making it suitable for solving ordinary differential equations, ODEs. Let's implement the pseudo-spectral method with RK4 using Python. We'll use a simple example of solving the advection equation. T U plus C x u equals 0. This code initializes a sine wave as the initial condition and evolves it using the pseudo-spectral method with RK4 over a specified simulation time. The pseudo-spectral method with RK4 is a versatile technique for solving partial differential equations. This tutorial provides a basic example, and you can adapt the code for more complex problems by modifying the initial condition and the governing equation. Understanding the principles behind these numerical methods is crucial for effectively simulating and analyzing physical systems. ChatGPT.